So optimizing surface area and volume, but there is a constraint. We're not going to be using what we could call, I guess, a normal type of shape when doing this 3D prism here. What we have is an open-topped box. Okay, so I've kind of tried to draw it out for us here. We do have a rectangular type prism, but there is no sheet on top. Okay, and this is actually very common when building materials. Usually they'll leave something open in case you're building something that's going to house something else. Maybe like a candle holder or plants or vases. This is common. Okay, so we have to create this shape, and we have 225 centimeters squared of material. Okay, we're going to make a pretty standard shape. It's a rectangular prism, but there will be nothing on top here. We need to find the max volume of this. Well, the first thing we actually need to do is figure out a formula for the surface area of this, because this is not a shape we're used to working with because it's empty here. So, there is one other thing. The bottom of this, they said they do want it to be a square, which makes sense, right? We know squares tend to be the most efficient shapes. The bottom face will be a square. So, since the bottom face of this will be a square, I know that the base and the height can both be written as the same variable because they'll be the same length. Okay? The height of this is unknown to us, though. We don't know the height, so we're going to call it h. Now, what they've done is they've given us the surface area, and we know that surface area is taking all of the faces and adding them together. Well, how many faces do I have on this object? 5, because the top is gone, right? So, the bottom face, there won't be a duplicate to it. So the surface area of this object, we'll just call it, I guess, O in this case, is going to be the area of the bottom. How can I find the area of the bottom of this? S squared, S times S. So we have S squared. And then what I have is 4 more identical shapes, okay? And the reason they're identical is because this is a square on the bottom. So how do I find the area of this face here? S times H, right? And since there are 4 of them, I don't need to find it for all 4. I can just find one of the areas for S times H and multiply it by 4. So what we'll be doing in this formula is adding 4 times S times H. Okay, we had to develop our own surface area to this object. Okay, so now that I've done that, they've told us the surface area is 225. So I can replace this, which stands for the surface area, with the number 225 is equal to S squared plus 4SH. Now, how many different variables do we have in this question? 2. We have a side and a height. In order to do this, we'll have to isolate one of the variables. Okay, and we're going to have to use trial and error. We're going to have to plug in numbers for that variable to find out which will give us the max volume. Now, I have 2 variables of S, which means it'll probably be easiest if I just isolate H. It'll be difficult because there are 2 S's to isolate S. So we're going to isolate H in this question because there's only one of them. So I'm going to move everything else to the other side. When I do that, first thing I'll move is my S squared. So I'll have 225 minus S squared. Okay? Recall that there is technically 2 terms here. This is one term and this is another. And this one's positive, so when I moved it to the other side, it became a negative term. Okay? So 225 minus S squared is equal to 4S times H. And we're trying to isolate H. How do I move that 4S, or even just the 4 to start with? We'll have to divide by 4. Now, technically, because there are 3 terms being multiplied here, it's 4 times S times H. I can move both of them at the same time. Okay? Think of them as one set together as 4S. So we're going to divide this side by 4S. You remember, like, we divide both sides by 4s. So I've eliminated 4s on one side, and I've now isolated h. H is all by itself on the right, and our equation is now 225 minus s squared divided by 4s. So it looks complicated. We developed all of this on our own. But what we've done is we've isolated h, which is great now. Because when we isolate h, we can plug in values for s. That'll tell us what our height is. And then we can test them out to see if they'll give us the best volume. So next what I'm going to do is I'm going to build a chart. I'm just going to pause this while we build a chart. We're going to do this together. Okay, so we've made a chart here. And this chart has 3 variables. S is these side lengths, and what we're going to do is plug values in. So we're going to make up numbers and put them in. We're going to put them into this equation, and when we've made up our numbers, 1, 2, and so on, that will give us a height. Okay? It'll give us an appropriate height that we can use with that constraint of 225 centimeters squared, I think it was. Then what we'll have is a side and a height that'll help us find the volume, but we actually haven't even developed the volume formula yet. How can I find the volume of this shape? What will it be? How do I find the volume of a rectangular prism? hs squared, or you're right, we would multiply the base times the depth times the height, and since the base and the depth are the same, we can simplify it as s times h, or s squared times h. So this will be the difficult part. Now the very first thing we'll do, start with a side length of 1. Okay? Side length of 1, we need to plug it into this formula here. So I'm going to do that once, and then from now on I'm going to work with the calculator. So you guys are going to have to follow along while we do this. 225 minus s, so we're replacing s with 1, divided by 4 times 1 will give us our height. This is one of the appropriate heights we can use. Remember, we're constrained because we only have so much material. So 1 squared will be 1, so we'll get 225 minus 1. 4 times 1 will be 4. It's equal to the height. That'll give us 224 divided by 4, which gives us a height of 56. Great. So our side length was 1. Our height was 56. Okay. I got to find the volume. Well, I got to do s squared. What is s squared? What's 1 squared? 1. And then multiply it by the height. What will 1 times 56 be? 56. So our volume will be 56 centimeters cubed. Okay, remember we're dealing with volume. Now it's probably safe to say that 1 will probably not be the best volume. So what I'm going to do is I'm going to jump up a bit. As long as the volume is increasing, I know I'm on the right track. So what number would you guys like to jump to?
4.
4? Sure. Let's jump up to 4. Okay, we're going to do this same formula here, but with the number 4. So 225 minus 4 squared divided by 4 times 4 is equal to the height. That's going to be 225 minus 16 divided by 16. And take a calculator out. 225 minus 16 divided by 16, 13.0625. We will be using decimals when we go through this. 13.065. Okay. We got 13.065. Remember, our volume is s squared. So what is s squared in this case? Let's find out. 4 squared is 16. And then I got to multiply it by the height, which is 13.065. Did our volume increase? Yep. Okay, so we're on the right track. We're 209.04. 209.04. Do you guys think we're close? What do you guys want to go to? You want to try 5 next?
9.
9? You want to jump up to 9? What will become difficult is eventually we're going to get a value that starts to lower again. So we'll actually have to find a peak, and then it'll have to come down again. So let's jump maybe to 7 and see if it's going up or down. If it's still going up, we'll continue going up. So same idea with the number 7. You would do that whole thing, and I'm not going to repeat it on the calculator because I think, are we okay with how to do that in the calculator? That formula? I'm going to tell you what the height will end up being. Okay? When it's 7, the height is going to be 6.2 0.85, which is going to make our volume 308. Okay? So this is good. 7's a good one. We'll go up to 8. We'll see if it's increasing. When we do 8, we're going to get a height of 5.03. And I've already got these answers here. You'll have to actually type them in the calculator. So this is a time-consuming process. And that would give us a volume of 322. Still going up. We'll try 9. When we have a side length of 9, our height is actually 4, a whole number. So that works out nice. And we're going to get a volume of 324. It's going up, but what I want you guys to recognize is the amount it's going up by. When we moved 4 spaces, we went up like 150. We moved 3 more, we only went up 100. Didn't increase by as much. We got to 7, and we moved from 7 to 8, it only went up, what is that, 14? 14, so we're not increasing by as much as we were off the start. We went to 8 to 9, we only increased by 2, so we're probably getting pretty close to where the top is. Let's try the next number, 10. 10, if we plug that in for side length, our height would be 3.125, which means our volume would be 312.5. What just happened to the volume? It went down, which means what? What was our best option for height? 9 and 4. Now, technically, there's probably a decimal number that's going to be even better for us. It might be between 8 and 9, or no, probably between 9 and 10, the height. Either 8, 9, 9, or 10, but for this purpose, I want us to only work with whole numbers. So that's a very long process to solve this, okay? We discovered that we needed a height of 4 and a side length of 9 to be the best shape to give us our maximum volume in this case, okay? So there's a lot of work when we're stuck with a constraint in a question.